Okay, so let's start. I'm going to share the problem and here. Okay, so we have discussed in detail the shape of this structure, which is a hoop. We have discussed that the formula we will be using will be the angular momentum is equal to the moment of inertia multiplied by the angular velocity omega. So in this case, we have to start with the first part of this structure, which is the carriages that are hanging from this structure. Now, each carriage we said could carry a maximum of 60 passengers. So this is the carriages in this case are called the passenger cars, and therefore we are using the subscript PC for the passenger cars. So the moment of inertia for the passenger cars is IPC is equal to the mass PC multiplied by the radius squared from the axis of rotation. And therefore we have each car is carrying 60 passengers, and if we assume that each passenger has an average weight of 70 kg, then the total mass of the passengers in one passenger car will be the product of this, right? So you can write that, and then the product of 60 multiplied by 70 plus the mass of the car itself, and then the total number of cars is 36. So after doing all this calculation, you get mpc is equal to this value. Okay, the rotational inertia, which is mpc r squared, again would be this mass, this value, multiplied by the radius, which we have been given as 38 meters. So you get this value. So you have these values, and you can find, um, you have found IPC, which we wanted to find. The second part of this system, one was the passenger cars. The second is the hoop itself, the structure itself. Now, the structure itself is having a mass of 3 into 10 raised to 5 kg. This is given. And we were given that the mass of the structure was about 6 into 10 raised to 5, and here we are talking about a mass of half of this mass. Okay, because we are assuming that it is rotating, and therefore we have the rotational inertia, which is given with this formula that we just discussed, and here we have the answer. Okay, so we used an assumption here. This is explained in this paragraph. And then finally, the total moment of inertia I will be the sum of the moment of inertia of the passenger cars that we just calculated here, and the moment of inertia of the hoop that we calculated here. And this is the total value, which comes out to be 1.22 into 10 raised to 9 kg meter square. The second part is the angular velocity omega f. The angular velocity we know is defined as delta theta, the change in angular displacement, divided by delta t, the time. So in this case, delta theta we know is the wheel is one complete rotation means 360 degrees. 360 degree means 2 pi radians. And since we're using the unit of radians, so therefore we will use 2 pi. So omega f is equal to 2 pi radians divided by the time taken for one complete revolution is 2 minutes. But this is not the standard unit. Always pay attention to your units that we studied in chapter number 1, because if you make a mistake in the units also, your answer will be wrong. So the 2 minutes have to be converted to the standard unit of time, which is second. So you convert the 2 minutes to seconds, and then you calculate this, and this is the answer that you get. So we have omega f, we have I, and therefore we can calculate the angular momentum L, which is a product of I and omega f. So we make a product of these results that we have, and we find the final answer. Is that clear?
Yes,
Yes,
ma'am.
ma'am.
Okay, right. So number B part is, this was part number A. Number B part is, if the fully loaded wheel is rotated from rest to omega f. Rest, when we say from rest, it means the initial velocity was, the initial velocity was 0. Okay.
At rest 0.
Yeah, at rest means 0. Okay, in a time period delta t1 is equal to 5 seconds, what is the magnitude of the torque, okay, of the average net external torque acting on it? Now we have to find the torque. In order to find the torque, we will use the formula that we just discussed when we were doing a review of the formulas and the concepts. The formula in this case, we already have the value of L. We have the value of T. So we can find the torque using the formula dl over dt. Okay. dl over dt means the change in angular momentum divided by the change in time. Okay, so the wheel rotates about a fixed axis to reach an angular speed. Omega f is the final speed. The initial speed was 0. So this means that delta L value will be the L that we have calculated here, because the initial angular momentum was 0 because the body was not moving. So this value comes over here and minus the initial one, which is 0, divided by the change in time. The time period in this case is given to be 5 seconds here. Delta t is equal to 5 seconds. So you put these values and you get the torque. Is that okay? Okay?
Yes, ma'am.
Good. So now I hope and I think you can give a good quiz on Friday. Please ensure that you don't have internet problems. Always have a backup. Like I am taking your class on my backup data because my Wi-Fi right now was having a problem. Okay. Again, charging your devices and ensuring. Go and sit in a room or a place where you know that you can manage this. Test your things before the quiz, and don't connect at the last moment. I want you all to be ready 1 hour before the class time. Okay, I will allow you to join 1 hour before so that you don't panic at the last moment. Okay,
Ma'am, I
ठीक
have
है?
a class before that.
जी कौन बोल रहा है?
Abira.
हाँ, अबीरा जी. अबीरा, what did you say?
Abira. Ma'am, I have a class before the,
बेटा
this class.
फिर आपकी मर्जी, आप जब मर्जी वो ज्वाइन करें, लेकिन आई विल गिव द परमिशन. ठीक है, लेकिन क्लास टाइम में
Okay,
तो
ma'am.
एटलीस्ट यू शुड बी अवेलेबल. आप फिर उससे
Yes, ma'am.
पहले अपना जो भी अरेंजमेंट करना चाहती हैं आप कर लें. ठीक है,
Okay,
एंड
ma'am.
स्टूडेंट्स हु आर अवेलेबल कैन ज्वाइन. ठीक है.
Okay, ma'am.
ओके ओके, टेक केयर.
Ma'am,
Thank you, ma'am.
as
Ma'am,
the quiz will be of
attendance.
50 minutes, so how many questions will be there?
बेटा क्वेश्चन अभी मैंने बनाने हैं. डोंट आस्क मी हाउ मेनी क्वेश्चंस, दैट डजंट मैटर. आपने अपने कॉन्सेप्ट्स रिवाइज करने, जो क्वेश्चन होगा आपके सामने वो आप सॉल्व कर लेना. राइट, इट शुड नॉट
Ma'am,
मेक अ
time management में help होती है
Ma'am,
जाएगा.
इसलिए
मैं
attendance
पूछ रहा
लगा
हूँ.
दी मेरी.
या आई विल गिव यू अकॉर्डिंग टू दैट. ठीक है.
Okay, ma'am.
ओके, टेक केयर. बाय.
Ma'am,
Thank you, ma'am.
जी, अब कौन बोल रहा है?
ma'am, चांद.
चांद जी. चांद,
Ma'am, attendance लगा दी मेरी.
तुम्हारी क्यों लगाऊं? मैंने जब तुम्हारा नाम बुलाया था तुम नहीं थे मीटिंग में.
Ma'am, था मैं.
बेटा मुझे नजर आ रहा होता है कौन है मीटिंग में.
Ma'am, मैं beginning से था.
चांद,
Check कर ली ma'am.
अच्छा मैं चेक कर लूंगी. ठीक है, बाय. लगी हुई वैसे आपकी नहीं? ठहरो,
Ma'am,
आज की नहीं लगी. आज की नहीं लगी आपकी.
Ma'am, मैं तो
तुम, मेरा
पूरे
ख्याल है
time
बाद
पे
में,
था.
मेरा ख्याल है तुमने बाद में ज्वाइन किया है.
No ma'am, किसी से भी पूछ ले ma'am.
अच्छा, किसी से क्या पूछना है? आई कैन सी इट माई सेल्फ. चलो ठीक है. ओके, थैंक यू. बाय.